mid-latitude cyclones. So I like saying that phrase because everyone's like, oh, cyclones are going to get into some good stuff. Not really. Tricked ya. The mid-latitude cyclones don't mean like cyclones and hurricanes. They just mean low areas of pressure. Now, mid-latitude ones really do cover a large area. This isn't the entire area that they cover. This is the entire area that they can occur in, okay, which basically is our continent, except for us down here, right? If we're going to get anything, we'll get the tail end of one of the fronts, and I'll talk to you about that as we go on here. Frontal weather. Wait, I thought we were just talking about mid-latitude cyclones. Yes, we were just talking about mid-latitude cyclones, but in order to understand those, you have to first take a step back and go into fronts. And what are fronts? Well, fronts are boundaries between different air masses. So we already know what the air masses is, and if you don't, go back a chapter. The fronts are just the boundary of it. Okay. Now at the front, there's little to no mixing. Okay. Yes, there can be some. That's why there's little, but usually there's not much. Okay. So little to no mixing of the air masses at the fronts, at the boundaries. And there's 5 types of fronts: warm front, cold front, stationary front, occluded front, and dry line. We'll go over each one. So, warm fronts. Warm air moves into cold air. Okay, so if you look at this picture down here, here's your warm air, here's your cold air. Your warm air is moving into the cold air. You can see the direction with the arrows, right? You can also see the type of clouds that they have: nimbostratus, altostratus, cirrostratus. Are you happening to see a stratus thing here, right? And then finally just cirrus. The other thing to note about warm fronts is the color of the front. They are red, okay? And they have semicircles. See the semicircles? Now, you can't just put semicircles on there willy-nilly. You have to put the semicircles in the direction that the air is moving. So it's kind of like little arrows pointing to this direction, right? The wind is going this way, and the arrows are also pointing that way, or these semicircles are pointing that way. Warm fronts are, well, they generally produce a lot of rain over a large area. I mean, if you haven't figured it out, right, the first cloud here is a nimbostratus, big area, like a layer of cloud that produces bad weather, right? Rain, snow, hail, whatever bad weather you want to think about, okay? Now, not usually thunderstorms, right? Nimbostratus, not nimbocumulus. So that's important. And they have these gentle, they have these gentle slopes that they go up. You can see a nice gentle slope as it goes above the cool air, right? It slowly rises, and that's why it produces rain over a larger area, because the slope is so nice. It just kind of carries it on. Okay? Indicators that it's coming, well, the cirrus clouds, as you can see here, and contrails, you know, the things that go behind planes, those last a little bit longer. Now, I can't really tell on that, but, you know, whatever. I don't look up the sky and time my contrails. Maybe I should start. That could be a good experiment. Alright, for those of you that don't like pictures, there you go. There's the chart for you. Cold fronts. Alright, so instead of the warm air going to the cold air, now you've got the opposite effect. The cold air is going into the warm air. And so you can see that down here. You can see the cold air direction, right? Well, what's happening to the warm air? It's getting forced up. And this slope is not quite as nice and gentle as the other ones, right? It's steep. And so this is forcing its way in, which is forcing this up, and it's forcing it up fast, which means you're going to build cumulonimbus clouds. Those are the thunderstorm clouds, right? So the air gets forced up, cumulonimbus clouds happen. That means quick, fast thunderstorms. So warm fronts for long periods of rain. Cold fronts are quick, fast thunderstorms. Now, how are they done? Well, blue, right? warm air was red, cold air is blue. Kind of makes sense if you think about your faucet on the sink, right? And instead of semicircles, you have triangles. And again, the triangles, you can't just put them on there willy-nilly. They have to go the direction of the air movement, right? So kind of like little arrows, like, hey, it's coming this way, let's go, right? Did I miss anything? I don't think so. Okay, again, there's your table. Okay, I'm going to let the song play the whole time. And you're kind of cheating because you're online, so you can just fast forward if you want. But in class, I don't let them fast forward this. We play it all the way through. Ready?
Such air masses extend over distances of thousands of miles and determine the weather in a region for several days. The weather changed and told, hi-ho, the weather, oh, the weather changes, I've been told, it changes day by day. The weather changes, I've been told, are caused by fronts both warm and cold. They cause the weather changes from day to day. The warm fronts, the cold fronts, a pushing and a wandering. They cause the weather changes from day to day. A warm front will occur, they say, hi-ho, the weather, oh, when warm air pushes cold away, it changes day by day. When warm air pushes cold away, a warm front's here, but not to stay. Because the weather changes from day to day. The warm fronts, the cold fronts, a pushing and a wandering. They cause the weather changes from day to day. Barometer shows pressures down. Hi-ho, the weather, oh, a warm air mass has come to town. It changes day by day. A warm air mass has come to town, and rainy weather hangs around until the weather changes some other day. The warm fronts, the cold fronts, a pushing and a wandering. They cause the weather changes from day to day. When cold air rises beneath the warm, hi-ho, the weather, oh, the warm air cools and clouds will form. It changes day by day. The warm air cools and clouds will form, and that can cause some thunderstorms. That's how the weather changes from day to day. The warm fronts, the cold fronts, a pushing and a wandering. They cause the weather changes from day to day.
Isn't that a fun song? That's a fun song. If you like more fun songs, you should join my astronomy class and learn the Faces of the Moon song. That one's fun. Okay, so this is another cold front, but it's called a backdoor cold front. Do you remember we talked about the nor'easters? Right, and the nor'easter had that air mass that kind of started over here. It's an MP, and it went off to Europe. And then it's like, oh, no, I changed my mind. I want to go back, right? And this is what it is. So you have your cold front. You can see just from the triangles that it's moving towards Boston. And you can also tell that by the arrows. But if you just start to look at the front, you can see it's moving towards Boston. Right. So this is moving east to west rather than west to east. Again, it's your nor'easter. So here you can see Boston is nice in the 70s, Bangor is in the 50s, and it's raining, right? As the front approaches, Boston is now in the 50s, and this is all kind of raining in Ickies, right? Because again, it's a nor'easter, so it's bringing that wet, cold air back into it. Now another little video for us. Lots of videos in this one.
All right, turn it up, folks. Mr. Wallace, get ready. You're about to get educated. I know we've all been talking about this backdoor cold front today, and you're sitting there. I just know you're dying to say, well, what is a backdoor cold front? Well, guess what? We got it. We got it for you here. It's just busting with joy. Normally, cold fronts kind of lined up west-east, and they march west-east, and they kind of come through in this direction. But look at this guy here. or gal, I mean, doesn't have to have a gender preference. It's coming down from the north. And in this business, we call that a backdoor cold front because it kind of comes in from the back or in a little bit different direction. So we come up with some sick stuff here as weathermen. Meteorologists are sick. We live on the edge. Now, this area of high pressure then back behind it will push the front to the south. So kind of a north to south thing rather than a west to east. Did you get that? Really not that tough of a concept. And it does look like we'll see some showers with it. So the impact's usually breezy conditions on the east wind. The cool air comes in from Canada. So we are seeing that, and it looks like it'll dominate over the weekend for the Boston Marathon. Stay tuned.
I realize that's probably how I sound to you guys, and that's probably how dorky I actually am. But, you know, I try to pretend in my mind that I'm more of a Joe Morosky thing, even though I couldn't run for the life of me, never mind hang from a wall. Alright, so, next one, stationary front. This one is... oh, stationary front. Every time I say it, I'm still like, no. Stationary fronts. Okay. Alright, pull together. Let's do this. Okay, stationary fronts are horrible. Let's just start by saying they are horrible, okay? You don't get airflow. Now, have you been in Florida with no airflow? Right, that's just, yeah, horrible, okay? However, not only do you have no airflow, you have a cold air mass and a warm air mass fighting for the same space, but neither of them are moving. So you have a front from a cold air mass, thunderstorms, rain, right? You have a front from a warm air mass, lots of drizzle and rain over a large area, right? So, and they just sit there. No one's going anywhere. And so you don't have the cold front moving in, you don't have the warm front moving in, you just have rain. Like, that's it, just rain for a long time, like days of rain. Icky. Now, what do these look like? Well, the next video will show you better, but basically you have your warm front, which is your red semicircles, and you have your cold front, which is your blue triangles, and they're trying to mix, but they're not mixing, they're just sitting there, right? So on the one side of the line, you're going to have red semicircles, on the other side you will have blue triangles. This will make sense once you watch the video, okay? Here we go.
It's a battle as old as time, a clash between hot and cold, spouses struggling over the thermostat. It's a stationary front, and it's this week's weather word. A stationary front is a boundary between hot and cold air masses that aren't moving, hence the name stationary front. These are much more common in the summertime when weather patterns don't move as much. You can spot them on a weather map because they look like a cold front and a warm front had a really bad head-on collision. They're the alternating blue and red lines. The triangles point away from the cold air, the half circles away from the warm air, signifying the direction each air mass wants to move. A stationary front means you can expect a lot of precipitation, usually rain showers and thunderstorms, because multiple low-pressure systems ride along this boundary like a train running over train tracks. With enough systems moving through the same area over and over and over, it can eventually lead to flooding.
So next one is the occluded front. Well, what happens here is you've got your warm front moving along, right? And warm fronts are a little bit slower than cold fronts. Again, slow, nice slope, you know, rain over a long period of time, right? So it's moving along, chugga, 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 right? But right behind it, there's a cold air mass that's also moving along. Chugga, 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 chugga. And so the cold air mass is moving a lot faster than the warm air mass. And so the cold air mass starts to take over. And when it does that, it reaches the boundary of the warm air mass, and the fronts start to eat each other. Right? The cold air literally eats up the warm air, and that's why it's called occluded. If you know anything about your mouth or dentistry, occlusion is your bite, right? The occlusion. Well, what do you do when you eat? You bite, right? So this is why it's called the occluded front. It's like eating the warm front. And when this happens, so they're both moving in the same direction. Unlike the stationary where they're moving towards each other, they're both moving in the same direction. So the cold front eats the warm front, and you get semicircles and triangles, but both on the same side because they're both moving the same way. And then the line becomes not red or blue, but purple. Okay, and so for all my arts people, there's your art for the lesson. There's your art lesson. Blue and red make purple. See, even in science, there's art. So this is actually a mid-latitude cyclone. So we'll come back to these pictures again. But look at what's happening here. This is a warm front. You can tell it's going this way because of the direction that the semicircle's on. The arrows help also. And this is a cold front, and you can tell it's moving down into the warm air because of the pointiness of the triangles. Again, this arrows help. But this is going, this is going. So what's going to happen is this moves faster than this one. So this is going to start to overtake it. And when it does, you get the occluded front. And so you get, see the purple color, right? Red and blue make purple. And then you have semicircle, triangle. And as it continues to move faster and eat into the warm front, you're going to get more of it. Semicircle, triangle, semicircle, triangle. So this is what I mean when I say Florida doesn't really get the mid-latitude cyclone, gets the tail end of it, right? Warm front, cold front. Sometimes we get the occluded front. But purple, semicircle, triangle, all the way down.
Red and blue make purple, but this week's weather word isn't an art lesson. It's occluded front, which is a complex frontal system, and we're going to break it down. I'm Storm Team Meteorologist Jason Myers, and occluded front occurs when a cold front overtakes a warm front. See, when low pressure systems are developing, they usually form fronts around them, warm front out ahead of it, cold front trailing behind. But in the atmosphere, cold air moves much faster than warm air. So as a low pressure system nears the end of its life, the cold front eventually catches up to and overtakes part of the warm front, resulting in an occluded front. When this happens, expect a lot of precipitation because at this point, we now have cold air and warm air pushing that moisture up into the atmosphere, causing more rain. It's like wringing out a sponge when you're finished with it. The low pressure system is done with all that moisture, and now it's getting rid of it.
All right, and last but definitely not least, dry lines. This one is kind of a yellowish color with semicircles, white semicircles, yellow lines, so kind of a different, like it looks like a warm front, but it's a dry line. Okay, the colors are off, so in black and white it's a little bit harder to figure out. But basically, this is when the cold air here meets the warm, moist air. So, and here you have dry air, here you have dry air, here you also have dry air. Also warm, but the basic thing is dry air. And again, sometimes you don't have this because this is in the summer, and usually this happens in like April. So normally you just have the CP and the MT. And you can see kind of a mid-latitude cyclone is going to happen. You can tell what's going to happen here. You've got the red warm front with the red semicircles and the blue triangles, so the cold front. And cold front eventually is going to overtake this warm front. You'll get an occluded front. But before that happens, right in between here, you get what's called the dry line, when the dry air meets the moist air. And what happens here, remember, fronts are little to no mixing, so there's a little bit of mixing, and you start to get severe storms, including lots of tornadoes.
Many look forward to the spring season, warmer temperatures and lots of sunshine, but over the South Plains that can signify a sharpening dry line, which can produce severe thunderstorms. A dry line is an invisible boundary that separates dry and hot air to the west and warm and moist air to the east. Over April and the springtime months, south winds begin to force higher humidity values into the South Plains and Gulf Coast states. At the same time, fronts blast down from the north and west, bringing in cooler, drier air. As storm systems collide within these air masses, the air converges at times on the dry line. This can then in turn trigger the development of dangerous and damaging storms. Now, a dry line in itself will not produce severe storms, but rather you need all the ingredients necessary for severe weather, including a strong jet stream and moisture. The dry line simply acts as the forcing mechanism that exposes all the elements in place and flips the switch from quiet to stormy. Back in 2007, this was the case as a dry line strengthened over the western plains, producing 82 tornadoes and millions of dollars in damage.